All right, so real quick, just in case you get asked how to do these questions here. So you see how this one says cotangent of 38 degrees. Your calculator does not have a cotangent button unless you have a CAS. So remember that cotangent is a reciprocal of tan. So you can either just do 1 over tan 38 degrees, but before we push this into our calculator, remember that we reset our calculator, so that means that our calculator right now is currently under... Did I close? I closed my calculator? Dang. Why did I close it? Okay, so your calculator right now, after you reset it, it's in radian mode, which when we take our AP exam, it's going to be always in radian mode. But here we go. So how do I go to degree mode? You click on mode, and 1, 2, 3, the third line down, it says radian and degree. You go over degree, highlight that, or push enter until that one's the one that's blinking. So there it is. Now degrees blinking. If you have a modern calculator, it'll tell you what mode you're in the top right. But if you have one of the older calculators, the yellow ones, it won't tell you this top line here. So there it is. Now I am in degree mode. So how do I type this in? The 1 over 1038. There's two ways to do it. You can literally just go alpha fraction and then put a 1 in the top of that and then 1038. And I guess you don't need that fraction feature. The fraction feature, you push alpha y equals. If you have a newer calculator, you can probably push alpha the x, the top left hand corner. Another way to do it, I guess, like I said, you don't need that fraction feature. You can just do it like this, guys. Parenthesis 1 divided by tan 38, close, close, or close, close, and then push enter, and you'll get the same answer. Do you need those parentheses in the outside? No, you can probably just get it by doing 1 over 1038 like this. All right. One more way to do it. Another way to do it, guys. Remember that cotangent is a reciprocal of tangent, right? You can just do this. Tan 38, close the reciprocal, close the parenthesis, and then push the reciprocal button. That's that x to the negative 1. And then check it out. Boop. Same thing. So you'll get the same answer no matter how you do it. Cool, right? So 1.2799. So that's what I'm going to write. 1.2799. 1.2799. Are you shocked that it is positive? No, 38 degrees, x divided by y. X and y are both positive, so it's positive. Look at this one, cotangent of 140. Before you say the answer, is it positive or negative? Negative, because 140 degrees is in quadrant 2, and x divided by y in quadrant 2 is negative. So I'm going to go 1 divided by tan of 140. And I got negative 1.1917 or 1918 if I round it. So negative 1.1918. So let me write that down. Negative 1.1918. Always at least 3 decimals after the decimal, but the more the better. Secant 238, that's the reciprocal of which one? Cosine? Yeah, you can say cos. So it's cosine. So positive or negative, but before even typing it in. Yeah, you're going to get a negative. So 1 divided by cosine of 238. Close it, push enter, and there it is, negative 1.8871. Negative 1.8871. Secant of 53, again, that's just 1 over cosine of 53 degrees. All these are degrees here. So 1 divided by cosine of 53. And we got 1.6616. 1.6616. Cosecant of negative 179. That's 1 over sine of negative 179 degrees. So 1 divided by 0.00 something, it's going to be negative something because negative 179 is in quadrant 3. So it's probably going to be a pretty big number or an integer or a number. 1 divided by sine of negative 179. 179 is really close. Sine of 179 or sine of negative 179 is really close to 0, right? So 1 divided by that, and there it is, negative 57.2987. Negative 57.2987. And then last but not least, you have cosecant of 180. Can you divide by 0? No. So, I mean, I guess you can try, but you're going to get error. So, undefined. Yay or nay? Okay. Now we're finally going to talk about waves. Guys, I don't know if you know this, but right now you're being bombarded by lots of waves. Lots and lots and lots of them. You got radio waves. You got sound waves. What you're hearing right now from my mouth, that frequency, that's a sound wave. You got light waves. You got sun rays that they're probably penetrating through this building. They're just not hitting you at full blast, right? Because we're blocking most of it. Look at all the waves they're getting hit. Every time you turn on the radio, that's a wave. Every time you answer your cell phone, that's a wave. It's not a radio wave, it's an electromagnetic wave, but it's a wave. Like, you're being bombarded by waves all the time. The microwave, well, I don't know if you know this, but there's research being done. They'll find out with you guys. Well, no, actually, you guys don't really. They'll find out with the millennials more so than you guys. They're trying to see if all those, when you hold, I know this is not a cell phone, but when you hold your cell phone here, all those waves going through your brain, they're trying to see if, like, that's affecting, if there's some type of effect going on up here. Because, I mean, that is a wave. Like, it would probably be pretty dangerous if you put your brain in a microwave, because if it can melt a Snicker, it'll probably melt like some of that fat. The brain's mainly fat, right? Like, okay. Anyways, I'm not a medical person, but you should probably be careful with those type of waves being near your this. Okay. I remember someone did an experiment. I think it was you guys too. They put a Wi-Fi router next to a plant, and then you got the same plant or a different type of plant, but the same style, and put it away from the Wi-Fi router, and you gave it water, and you wanted to see like how it grows, and the one next to the Wi-Fi router grew like very slow. Was it you guys? That was one of someone did it in this school. I thought it was here. Okay, or maybe I read it somewhere. But it's all good stuff, guys. You're being bombarded by waves, so this is why we study waves. All right, property of sinusoidal waves. Draw a wave. My wave sucks, but that's fine. Draw a line through the middle. That's going to be called the midline, hence middle. Midline, sometimes called sinusoidal axis. Have any of you guys heard of this through camp or something? No? Okay. This upside down bowl, I guess you can call that, we're talking about concavity, so I'm going to say this is concave down. This, what's up?
Is it called the sinusoidal axis because that's the sine graph? Like, it's the sine graph, and then it's just like going, it's the axis. Never mind.
Keep going, miss. That point right there that cuts it from concave down to concave up, that's called a point of inflection. So that's also a point of inflection. We call the distance from the peak to the midline, we call that the amplitude. Let's see, what else? Okay, my wave was supposed to be uniform, but it's not. That's fine. Hopefully your wave is more uniform than mine. From peak to peak, that's called a period. You can also call that one cycle. It does not have to be peak to peak. It could be point of inflection with the graph decreasing to point of inflection with the graph decreasing. That is also a period or one cycle. %25 of a cycle happens from the midline to a max. 25% of a cycle. Or you could also say from a max to a midline, or from a midline to a min. I think think we've covered it. Oh, okay. A few little things. Frequency. Frequency is known as the reciprocal of period. Let's see, what else? We're going to do waves like this. Y equals A cosine B x minus C close plus D. I'm just going down the alphabet. It does not have to be cosine. It could also be sine. Y equals A sine B parenthesis B x minus C close plus D. Yeah, A, capital A, and then cosine. Cosine is a sinusoid. Cosines and sines, we just call them sinusoids. They just differ by a phase shift. It's still a wave. B parenthesis x minus C close plus D. Have I done anything crazy yet, guys? No. The same rules apply. The same rules apply as to when you were in algebra. So if I turn the page, and don't worry about getting all this, we'll hit it again. If I turn the page, I give you guys, so here it is again, see? General sinusoid equations, bam and bam. Where the A stands for amplitude, technically A is the vertical dilation. If negative, reflection from parent function on the x-axis. You know the deal, basic algebra stuff. That's why we put absolute value in there. B will get you the horizontal dilation, same deal as when you were in algebra. C in waves is known as the phase displacement. Basically, it's your horizontal shift from your algebra days. And D is the location of the sinusoidal axis, basically your vertical translation or shift. Don't worry, we're going to do this over and over and over again. And then, of course, we already said here, period is 360 divided by B if you're in degree mode, or 2 pi divided by your absolute value of B if you're in radian mode. The period of the parent function should be 2 pi. So from here you can get your B, right? So this means that your B is 360 degrees divided by period, or B equals 2 pi divided by period. Yes. Oh, yeah, go ahead. Okay. And then frequency is just the reciprocal of period. All right, guys. Now I don't want you guys to freak out. So hopefully I still have it here. Hopefully my internet connection is fast enough. Look, all these sinusoids are going to be derived from your unit circle. Look at this, guys. So there's my unit circle, and look at the blue outline. It's coming from here, the distance from the origin. See? Bam. This is -1, so -1 down there. Then the distance, let's see, boop, back to 0. And if you were to do the green outline instead of the blue outline, it would graph the other one. Cool, right? Did you guys get to see that wave? So that's where it comes from, guys. So let's go ahead and I'm going to close all this right here. So don't worry. Which one do you guys want to do first, the cosine or the sine? The sine? Okay. So here we go. I'm going to sketch. Let's see, what am I going to sketch? I'm going to sketch the y-axis and the x-axis like so. The high is a 1, so I'm going to put a dotted line at 1. That's a 1. And I'm going to put a dotted line at -1. You guys like degrees, so I'm going to start at 0 degrees. I'm going to call this guy -90 degrees. I'm going to call that guy 90 degrees. 180 degrees. 270 degrees. 360 degrees. At 0 degrees, what is sine of 0? What is it? We just took unit circle quiz. What's sine of 0? I don't know. Not sine of 0? It's not 1. 0. Put a point at 0, 0. Sine of 0, 0, guys. Put a point at 0, 0. What is sine of 90? Sine of 90, you're on the y-axis. 1. Go to 90 degrees, put a point at 91, at 90 comma 1. What is sine of 180? Back to 0, put a point at 180 comma 0. What is sine of 270? So go to 270 comma negative 1. What is sine of 360? 0. And since I put negative 90 on mine, sine of negative 90 is negative 1, because that's like sine of 270. Cool or not cool? Will they ever ask you for what? Sine of y? What do you mean? Oh, I'm telling you that it's a relationship. Sine x equals y. So I'm plugging in a 0 in there, and whatever I get, I'm plotting in the y value. See? So they can't, if they were to, I mean, I guess they could ask you sine of y, but then I'd have to make my x-axis the y-axis, you know what I mean? Because it's sine of something equals an output. Okay, here we go. Wherever you have a max, try to make like a bowl-like, upside-down bowl, but aim the ends towards the point of inflections. Wherever you have a min, make like a bowl, but aim it towards like your bowls of inflection like this, see? Like that. And then when you cross your midline or your x-axis, try to make that x-axis look like a point of inflection where you change concavities from concave down to concave up and vice versa. And there it is. There's your first sinusoid. You guys like it? Okay, let's do another one. This one will be more fun. I'm going to sketch the y-axis here. And I'm going to do, I guess I'll do it the same. And max, min. And then let's see, 0 degrees, negative 90 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Okay, you don't have to be perfect, guys. It doesn't have to be perfect. Cosine of 0. What's 1? So go to 0 degrees, put a point at 0, 1, way up there. That's your max. Cosine of 90. 0. Put a point at 90, 0. Cosine of 180. Negative 1. Cosine of 270. 0. Cosine of 360. 1. And in my case, I have negative 90 here. So negative 90 is like 270. So cosine of 270 again is 0. So there it is. This one looks a little better than the other one. Wherever you have maximums, put an upside down bowl there. Where you have minimums, put a bowl. Aim it towards your points of inflection. Try to make your midline where it changes from concave up to concave down and vice versa. And check it out. That looks pretty cool. What's up? Oh, I just wanted to do the negative 90 just to have more points so it could look prettier. So it could look more like a wave. I can see that I didn't do a good job. I can see that this part of my wave looks like pretty tight, and then this part of my wave looks kind of big. So I didn't do an awesome job, but that's fine. Are we still okay? What happened, Lazardi? Yeah, all I'm doing is those special dots. Cosine 0, cosine 90, cosine 180, cosine 270. That's why we got to know that unit circle. That's why we didn't do these notes until we've done the unit circle several times. So all right. Here we go. So check it out, guys. So it says, example 1, suppose that a sinusoid has a period of 12 degrees per cycle. So there it is, that's my period. Amplitude of 7 units, that's your A. and phase displacement -4. That's your C. With respect to the parent cosine function and a sinusoidal axis 5 units below the x-axis. That's the D. So don't worry, we're going to go slow. It says with respect to the parent cosine function. So here we go. I am 5 units below the x-axis, so I'm going to exaggerate quadrant 4. So let me start exaggerating quadrant 4. And I'm going to go something like... Yes. I could have done... No, I couldn't have done anything else. It tells me that I'm 5 units below the x-axis. I guess I could have done quadrant 3, but I want to have positive thetas. So that's why I chose quadrant 4. Because I don't want to have negative thetas. I'll probably have a little bit of negative, but not a lot. All right, here we go. So my midline is 5 units below the x-axis. So that's a -5. So I'm going to say this is -5 right here. That dashed line is my midline. Yes. Yes. It's below the x-axis. Well, my midline is horizontal, so you know what I mean. Like it has to be below the x-axis. My midline goes left to right like this, so I can't. You know what I mean? All right. I haven't done anything crazy yet. All right, guys, focus, focus, focus. What's your amplitude? 7. So from the midline, I'm going to go 7 up and 7 down. 7 up. So 7 up, I'm going to be way right here. I'm going to call that 2. Yes. From the middle, you go up 7. From the middle, you go down 7. That tells you how big your wave is. I'm going to go down 7. And, man, I should have left more space in here. Dang it. That's fine. I'm going to say this is, because I want it to look uniform. And I know, mine's like below that. That's fine. -7 minus 5, what's that? -7, 8, 9, 10, 11, 12. -12. I want it to look uniform, so there it is. Are we still okay? All right. Look what it says, guys. Okay. Everyone put your pencils down. It says with respect to the parent cosine function. I want you to notice that the cosine function has a peak right on the y-axis. Do we observe that? Do we notice that? So I'm going to move 4 degrees to the left of the y-axis, and I'm going to put a point at the max. Chav, why are you doing that? Because notice that I have a point at the max right on the y-axis on your parent cosine function. Yeah, you moved it 4 degrees. That's the reference. So I'm going to go 4 degrees to the left. I'm going to call this 4 degrees. And I'm going to put a point like that. So go ahead and do that now. Okay. I'm going to go slow. How many degrees is one cycle? 12. So that means every 12 degrees I have another maximum. Does that make sense to you? Okay, so that means I'm going to go another 12 from -4. So 4, 8, 12. So I'm going to be right, where am I going to be? Right here at 8 degrees. Do you guys see that? -4 plus 12 is 8. And I'm going to put a point at the maximum. Cool or not cool? I'm going to go another 12. What's 8 plus 12? So I'm going to say 20 is like right here. And I'm going to put another point at the maximum. I'm going to go another 12. What's 20 plus 12? And I'm going to put another point at the maximum. I'm going to go one more. What's 32 plus 12? So here it is at 44 degrees, another max. And I'll wait for you guys to catch up. Are we okay so far? Okay. Notice in between your max, in between your peaks, you have a, what is this called? A min, yeah. Did you say min? A min. So in between those maximums, you have a minimum. So where is my minimum going to be at? Well, let's see. It's 12 degrees per cycle, so that means I got to go 6 degrees from -4 to the right. Does that make sense? So if I go 6 degrees to the right, that means I'm at 2. It looks like the middle is like right there. No, not quite. I just went halfway. I went halfway of that 12. So in between the two peaks, you have this guy, and that's halfway. Does that make sense? And put a at 2, put a one at -12. Are we still okay? Okay, now I'm going to repeat that every 12. So what's 12 plus 2? So notice 14 is equal distance from 20 as is 8. See? The difference between 14 and 20 is 6. The difference between 8 and 14 is also 6. Go another 12. What's that? 26. And go to 26, -12. Go another 12. 38, and go to -12. There it is. I think that it's looking good. Don't connect them yet. Now from your max to the midline is a quarter, right? A quarter of a cycle. So what is half of 6? 3. So from -4, if I go 3, so that means I'm like -1 right there. And I'm going to put a point at the midline. See? Do you guys see what I did? 2 add 3 to that. That's at 5 degrees. And I'm going to put a point at the midline. 8 add 3, 8. 9, 10, 11. I'm going to put a point at the midline. That's 11 degrees. 14, 15, 16, 17. Put a point at the midline. After you do a few, you don't have to keep labeling them. Just put a point right smack in the middle between max and min. Make sure it goes in the midline. Yes. I would connect it like this. Do the highs. Upside down bowl. Aim it towards your points of inflection. Do the lows. Aim it towards your points of inflection like this. See? And then connect. Try to make your points of inflections where it changes concavity from concave down to concave up. Doesn't have to be perfect. And look, OMG, your first wave. I actually saw yesterday something about sunspots and the cycles. So we're actually going to be able to predict. We're going to make sure, we're going to see if the prediction that NASA is making is true based off of what we know already. How do we feel? They told me all of those. They told me where my midpoint was, the 5 units below. And then I found the maximum by just going 5 plus 7, or -5 plus 7. Because they told me my amplitude right here, see? So I went from the middle, and I went up 7, and then from the middle, and I went down 7. The 12 degrees is the cycle, so it repeats every 12 degrees. And then the -4 was a shift from the peak, from the y-axis, 4 to the left. Ask me. Yeah, because cosine, see how cosine was already right on the y-axis? So I had to go 4 degrees to the left of that. See, it tells me right here. With a phase displacement -4 degrees with respect to the parent cosine function. So this is my cosine function. Move 4 to the left. That to the left, yeah. All right.
So it's 5, and then you just add -5 plus 7, and that's how you get
-5 plus 7, -5 minus 7. Letter B says find the equation for the graph you sketched. Okay, well, Y equals A cosine open parenthesis B open parenthesis X minus C close plus D. Let's see. Ready, guys? Y equals, what was my amplitude? 7 cosine, open parenthesis, the B. Well, the B, we get it. Look at your notes. Way up here, it says that B is 360 divided by period. We knew what our period was. So 360 divided by, what was the period again? 12. So take your calculators, go 360 divided by 12. What do you guys get? 30. That's the B. Open parenthesis. X minus, my shift was -4. So x minus -4, that turns it into a +4, close. What was the midline? -5. Now, below. Now we're all going to practice typing this into our calculators. So take your calculator, guys, and go to y equals. It should be empty now because we reset it. And go 7 cosine. And we're going to type in 30. It already opens a parenthesis for you. Open another parenthesis and go x plus 4, close it twice. Close. So there's the number one mistake that we make. Make sure that you close it twice. Yeah, the y equals in the top left-hand corner, guys. Sorry. Y equals in the top left-hand corner. And then what am I going to type in here? -5. And just for kicks, I want to see the midline. So I'm going to go ahead and type -5 in y2 because I want to see the midline. Don't push graph yet. Okay, ready? Don't push graph yet. Oh, yeah. The X is next to the alpha. You don't have to push alpha, you just push the X. Yeah. There's your X button. Ask me, Lazardi. No, make sure that are you typing this in your calculator? On the top left-hand corner, there's a button that says Y equals. Hit it. Top left, Y equals. Hit it. Yeah, that's what happens when you hit that button. No, that was an airplane shadow. All right, here we go. And then type on that expression. The X is next to the alpha key. Click on window. I want it to look like this one. So let's see. I'm going to go to negative. I'm going to go a little bit past that -4. So I'm going to go like to -7. So X min -7. The negative is next to the enter. -7. And I'm going to go all the way. Let's see. It says 44 there. Let's go to 50. I haven't done anything crazy. I clicked on window. All right. X scale. I'm gonna make it by 10. So a whole bunch doesn't come out in the bottom. Y min. What's the lowest Y value? -12. So I'm gonna go to -15. So -15. Y max, the biggest value is 2, so I'm going to make it like 5. Yeah, you said it. Y scale by 1, that's fine. So here's how mine looks. You don't have to worry about the resolution or delta X or trace step. That's fine. And now check it out. I'm push graph and look what happens. Okay, where are we at, guys? So you didn't get that, Lazardi? Yeah, this is why I told you be careful with these parentheses here. Did you put 2 of them? Oh. You're gonna love this part. All right, let me see, guys. haven't put the minus 5. Okay. Does everyone graph look like this? Okay. I think we're all here now, hopefully. Is everyone here? Oh. All right, who's not here? It might be your mode, or it could be an extra parenthesis. Oh, yeah. This is the thing. Yes, he went in, make this one negative 15. All right. All right, guys. So how do we know that this graph is our graph? Like our graph uniquely. So look, check it out, guys. Check it out. Everyone focus, focus. I know that at -4, I better be at a peak of 2. Do you guys see that? So let's see. This is just a machine, a tool like anything else. Push the trace button. And then it's going to say, okay, where do you want me to trace? And you can just go right to -4. So push -4 and push enter. Do you have a point right at the peak of 2? Yes. You don't have to push trace again. I know that I'm at the midline when I'm at -1. So now you can just push -1, enter, and check it out. It's right at the midline. If you want to see the midline, you have to put -5 on your Y2. But look, there it is, -5. And then I know that I have a minimum when X was 2 degrees, right? So I'm going to push 2, and I'll push enter, and check it out. It says -12. So that's how I know that this is the correct graph, and we're good. Does that make sense? Of course, if you have Desmos is superior. You get a better picture, but you're not going to have Desmos on your exam. Like, you know what I mean? Like on your AP exam, you're not going to have Desmos. You're going to have your calculator, this one. So, yeah, so there it is. All right. So I think we're good. Now go to the next page. Yes. Yeah, go ahead. So now here we go, guys. You have a graph, and we are trying to figure out what the equation for that graph is. So right now, the one that you guys know how to use is cosine. So I'm going to write y equals a cosine b x minus c close plus d.
And that equation only works for cosine or for all of them?
For all of them. Because cosine and sine are both waves. So we could have done a sine one if we want, but right now we only have experience with cosine because that's the only one we've done. All right. Are we okay so far? I haven't done anything yet, guys. We're okay so far? All right. Check it out. So it wants us to figure out, let's see, for the sinusoidal below, give the period, frequency, amplitude, phase displacement, and sinusoidal axis location. That just means midline. Write a particular equation of the sinusoid. Okay, let's figure it out. So the first thing that I think is easiest, to figure out our midline. How do you figure out the midline? It's in the middle between your high and the low. How do you figure out middle for anything? Add them and divide by 2. So what's my high? The 56. Yeah, you want the y value. 56 plus, what's your low? So go 56 plus -38 and divide that sucker by 2. Let's see, 38, 48, 58. That's 18 divided by 2. So I got a 9. Did you guys get a 9? Okay. Yeah, make sure that you try it out because I make mistakes all the time. Are we still okay? Okay, next. I'm going to get my amplitude. So 9 is kind of like, let's see, 10, 20, 30, 40, 50. So this, it's kind of like right almost there. Not quite at the 10, but really close. So the amplitude is the distance from that high to the midline. So amplitude is going to be 56 minus 9. What's that? 47? There's my amplitude. Are we okay so far, guys? All right, I got my amplitude. So I got my midline, I got my amplitude. All right, now let's do the C, which is the shift. If this were cosine, I would have the peak right on the y-axis, but it's not. Where's my peak at? At 3. So that means 3 to the right. Lazardi, did we understand that? No? Okay. Look over here, Lazardi. The cosine x has a peak right on the y-axis. Is this peak on the y-axis? No. Where is it at? 3. So it moved 3 to the right from where it should have been if we're using cosine. Bless you. Does that make sense? For sure. Well, there's nothing on the other side. I mean, there is, but we could use the other peak, but we don't see it. We could use it. All right. Heck, we can use the 23 if we wanted to. Yeah? Okay. All right. Let's see. What else? I'm just missing the midline. Oh, I already got the midline. I got everything I need except for the B. So the B is 360 divided by period. So let's figure out what the period is. Period equals. So I have a peak at 3 and I have another peak at 23. So 23 degrees minus 3 is 20. So I'm going to come back and I'm going to go 360 degrees divided by 20 degrees. And that's going to give me, what is that, 18? So there it is. I got everything I need. Y equals amplitude. What's the amplitude? 47. And I'm using cosine. 18 parenthesis x minus, or x minus or x plus? Minus x minus what? 3 degrees. Close it twice. And then what's your midline? 9. Are we ready to test it to see if that's our graph? All right, go to your calculator again, and we're going to start from scratch again. The y equals is in the top left-hand corner. Let's clear both of them. Clear. And what was the equation? 47 cosine 18. It opens a parenthesis already for you. Open another one, 18. And then x minus 3. Close it twice. Close. And then what was the midline? Plus 9. And then I like to see the midline again. So I go to Y2 and I push 9 again. Don't push graph yet. And does everyone know why I'm putting 9 on Y2? Because I like to see the midline. That's me. All right. Click on window. So now let's see. I'm going to go from, let's see. This is 5, 1, 2, 3. Go to negative, make x min negative 5. Negative 5. X max, make it, let's see, it goes all the way to 25, 26, 27. Make it 30. X max 30. The X scale, maybe make it by 5. Y min, well, let's see, it goes all the way to negative 38. So maybe make it negative 40 or negative 45. Y max, make it, it goes all the way to 56. So make it like 65. X max 65. Y scale, make it 10, so there's not so many little hash marks. And I think we're good. Let's push graph. Yeah, mine does it way faster because mine's on a laptop, right? All right. How do we know that this graph is the graph that we have here? What button am I going to push? Trace. I'm going to push trace and I'm going to push 3. Push enter. Is it at 56 at 3? Yes. Let's see. What else should I know? At 13, it better be negative 38. So I'm going to put 13, enter. And look at that. It's negative 38. And if you wanted to check the other one, at 23, it better be 56. Put 23, enter. We got them all. Do you see how we did it, guys? Okay. Are we getting better? All right. Let's go now to example 3. Don't worry, there's our last example, and your homework's even easier than today. That's because I messed up because of the picture day. I really wanted you guys to mess around with this, but we'll do it in the next class period. All right. The figure below shows a quarter cycle of a sinusoid. Write a particular equation and check it by plotting it on your graphing calculator. Okay, right now all we know is cosine. We haven't messed with sine yet. Don't worry, we'll have more fun next time with sine. This right here is 25% of a cycle. So that means that this 8 better be a midline because it looks like it's a point of inflection. And that 3 looks like it's a low. Do you guys see how that looks like it's a low? Yeah, it flat lines. You can see that you have a horizontal tangent right at 24 degrees. The distance or the gap between 17 and 24, what's that, 7 degrees? So so there's 2 ways to get the period, but I guess let's not talk about that just yet. The difference between 8 and 3, is that 5? So that means if I go 5 up from 8, 8, 9, 10, 11, 12, 13. So this gap right here at 13, that's the max. Because I want to draw it. You know what I mean? I'm going to draw it out. Okay. At 17, that was a point of inflection. I'm going to go backwards. So that means at 10, let me see if I can draw it perfectly. At 10, I have a peak. So at 10, go to 13. Chav, how'd you know you have a peak there? Every quarter of cycle, you from max to min point of inflection is a quarter. From point of inflection to min is a quarter. So there it is. That's all I want. I just want that 10 one. Let's see. I'm going to go 24 plus 7. What's that? 31. So at 31, I'm going to put a little hash mark, 31 degrees. And I'm going to put a point at 31.8. So I'm going to start making it go up. See? And then 31, I'm going to add another 7. What's that? 38. And I'll put a 38. I'm going to put a point at a max. How did I know it was 13? Oh, the difference between 8 and 3 is 5. So the difference between 13 and 8 better be 5 as well. Does that make sense? Okay. Are we okay so far, guys? Okay. Here we go. The period. There are 2 ways to get it. You don't have to do it like this. Peak to peak, 38 degrees minus 10 degrees. So I see at 28 degrees. That's one way. Or you could have done, what else could you do? Or you could have done 7 degrees. That's a quarter. So to complete your quarter, to complete your cycle, multiply 7 degrees by 4. And there you go. You got your 28 degrees to complete your cycle, right? So yeah, because the 7 degrees was a quarter. So there it is. 2 ways to do it, guys. It does not matter how you do it. Amplitude. Amplitude, we either did 13 minus 8 or 8 minus 3. It does not matter which one. They're both the same. Let's see, what do I need? Y equals A cosine, open parenthesis, B, X minus C, close, plus D. I need the B. The B is, it should have been 360, the parent function, but it's not. The period is 28 degrees. Oh, this is not going to be pretty. That's fine. Turn it into a fraction, guys, because this one's going to go forever. So look, second quit, 360 degrees divided by 28. See how you get this ugly decimal? Just turn it into a fraction. Math, fraction, enter. 90 over 7. So put 90 over 7. All right, your C. We're using cosine as a reference. Where's my first peak at? So 10 degrees to the right. And then finally, your midline. Where's your midline at? 8. All right, here's my equation, guys. Y equals, let's see, 5 cosine. 5 cosine, open parenthesis, 90 over 7, open another parenthesis, x minus 10 degrees, close, close, plus 8. We're going to check it to see if it is correct. You guys ready? I'll wait. Type it into your calculator. I'm going to go y equals. I'm going to clear both again. And I already forgot it. What was it? 5 cosine 90 over 7. I'm going to use the alpha feature to get my little fraction. 90 over 7. And then open parenthesis, x minus 10. Close it twice. Close, close. And the midline was what again? Plus 8. Don't push graph yet. Click on window. Let's see, what are we looking at? I'm going to make x min 0. X min 0. X max, I'm going to make it 45. X scale by 5, that's fine. Y min, I'm going to make it 0. Y max, I'm going to make it, let's see, we go to 13. I'm going to make it 15. Y scale by 1 or by 5, it doesn't matter. Graph, and there it is. Oh, I want to see the midline. Let me go to Y2. I'm going to put 8 so I can see it. Okay. There's my midline. It looks beautiful. Let's see. I'm just going to look. I just want the original points, guys. I'm going to push 17. I'm going to push 24. And then I'm going to test one of my peaks. So I'm going to push trace, 17, enter. Yep, check it out. It's right there at 8. If I push 24, so I'm going to push 24 and then enter. And look, there it is, right at 3. And then I want to test one of my peaks. I'm going to test the 10. I'm going to test the 38. So I'm going to go 10. Bam, I have a peak there. Yep, and I'm going to test the 38. Voila. Look at that. Aren't you guys happy? Did you guys already know how to do sinusoids before today? But now you know how to do them, right? Like more or less. Now we need more experience. But isn't that cool that you're learning the math of pretty soon you're going to be engineers and physicists like doing waves like crazy. Like, oh yeah, look at this sinusoid. This is red, this is blue, so this is moving further away from us. That's getting closer to us. All that good stuff. Isn't that cool? That's life. All right, guys. I wanted to give you guys a handout initially to go over all this stuff that we've been doing, but we're not.